Hello and welcome back to Red Right Hand Forge. This is Marshall, and in this video I'm going to make some Damascus, or I'm going to try to anyway. I want to do a twist pattern Damascus because that's what I want for the next blade build that I'm going to do. And incidentally, I think that twist Damascus is really one of the easiest methods out there, at least the easiest for getting a high layer count. Because unlike other methods where you're welding your initial stack of steel together and then putting it in the forge welding it, drawing it out, chopping it up again, and you have to clean up all those individual sections, restack them, re-weld them, then put them back in the forge, reforge weld them, draw it out again, and rinse and repeat until you get to that desired layer count. With a twist pattern, you just have to forge weld your initial stack, and then once you draw it out to a good twistable size, the action of twisting actually creates those layer counts for you. So I think, it saves you a lot of that challenge and rigmarole of what you normally have to go through to get that super high layer count. I'm not really trying to take a shortcut, I just happen to want that pattern for my next knife, but this is probably a good video to start when it comes to building Damascus, and it's my really first video for going into any detail on my process. So I'm going to really try to break that down, and of course if you have any questions or comments, just drop them down below. I'll definitely get back to you on that. Yeah, let's see how this goes and get right into it.
Cleaning your steel for your weld up is very important, not only for welding the stack together to prep for the forge, but the forge weld itself is really going to go much better for you if you've got all the mill scale and other impurities out of the way. I like to use this wire cut brush while the lengths of steel are still intact. You also want to make sure you're keeping track of which steel is which. I'm using 15N20 and 1084. We can just call it bright steel and dark steel. The 15N20 won't etch, and the 1084 will. The nickel content in the 15N20 steel will resist the etch, and the 1084 doesn't have that nickel content, so it's going to etch darker. While you're chopping these pieces up, you want to make sure you keep track of that all along the line, and you'll notice I'm doing that, keeping them in separate piles and labeling them when I can. After I clean off the mill scale, I just like to take them over to my cutoff wheel here, and then over the grinder to clean up the edges and prep the stack for weld up. I like to use kerosene to clean off any leftover oils or residues that are on the steel before I start to stack them. You'll note that I'm still being very careful to make sure that I know which steel is which, so that when I stack them, it's an alternating steel for every layer. I probably made this billet a bit too big. I wanted to get 2 blades out of this, and I don't think that's going to be a problem, but you'll see towards the end of the video it gets kind of unworkable because of how much steel I put together here. Or at least I should have chopped it in 2 sooner than I did. But you'll see, I'll have to work around that when I'm actually doing my knife build videos, which I will put in the description once I actually make those knives. But for now, this video is just focusing on the Damascus itself and my process. But that's one thing I wanted to point out. You want to make sure you have enough to do the projects that you have in mind, but there is such thing as too much steel, and in my case, I bit off a little more than I could chew, and I didn't handle it when I could have and should have to make it easier on myself. But ultimately, I think everything's going to work out fine. I'm not the greatest when it comes to welding, but really just need to hold these edges together for the initial forge press. So that'll do. We drop it in here and get up to forge welding temperature. That takes a while. This is a big stack of steel, and you can see in this shot here that the top layer is heating up a lot quicker than the intermediate and bottom layers. It may not be a problem. Ultimately, it will probably get to uniform heat, but for me, I just figure why not eliminate the potential for a problem, so I've decided to just take this out and rotate it. Again, this is probably an unnecessary step because thermodynamics will dictate that eventually this thing will all kind of balance itself out long before it gets to that forge welding temperature, but I just feel more comfortable watching it reach those temperatures in a more uniform fashion. Once this gets up to kind of a, I guess, jack-o'-lantern orange color and it looks uniform in that color, like you see here, this is a good time to add your flux. I'm using borax. This just gets down in between those layers of steel before we've pressed anything, and it kind of forces out the oxygen, and it helps minimize the oxidization between layers and the slag, and it makes for a much cleaner, reliable weld. While this is getting up to forge welding temperature, it's a good opportunity to go over and preheat the dies on your hydraulic press if that's what you're using. It's not as important if you're using a power hammer because the power hammer only comes in contact with the steel for a split second at a time. But the press really is putting pressure on there and holding contact, and it can draw out a lot of the heat from your billet, and that's just not efficient. So if you preheat them now, it just you get a lot more work time underneath the press, and it's just, in the long run, it'll save you a lot of hassle. As you can see, I'm getting up to what I call this stick of butter color, and once it reaches that uniform yellow color, I let it soak in there for about 15 minutes, at least for this size billet, and that varies depending on how much steel you're working with. But once it's soaked in there for about 15 minutes, it's ready to go for our initial forge press. And on this first pass, you can see I'm really not going crazy with it. It's just kind of getting everything set. You don't want everything to squish around. I probably went a little too far there on the front end if you saw that. So I guess I would say a little bit less than what I did there. Ultimately, this works out fine, but you do have to be cautious. This is a strong hydraulic press. I think this is a 29 ton. And it'll really squish the heck out of this thing and ruin your project if you're not careful. So just tap it on those first couple passes. And then for the next hour or so, I'm just going back and forth between the forge, the power hammer, and the press to clean up the edges, draw it out a little bit, flatten it, and get to the size I want before I put it into the squaring off dies in my press. You can see that my little welded handle at the end of the billet is starting to come detached. That's pretty par for the course for me. I always seem to struggle with those handles. It did last a good long while through the process here, so I'm not going to complain. And it would be easy enough to weld another one on there, but at this point, I just decide to just grab the steel itself with my tongs, and periodically I'll switch ends, and that's how I work around it. Just a few more passes here to get it to the desired dimensions, and then I'll put it into the vise and start my twist up with the little twist tool that I made, which is just a pipe wrench with a couple pieces of rebar welded to the top of the jaws. And the last step before I start twisting is just to round these corners off along the length of the billet with my power hammer here. Just that way when you start to put your twist in, those really harsh corners, they could potentially kind of rip, and obviously we don't want that, so just rounding them off a little bit can help prevent that. Got to work fast here, but you also have to be careful. It takes me a bit to get into my rhythm, and even though this is all super hot steel and it's workable, it's a lot of steel, and it is really hard work. If you've ever tried to turn one of these things, it takes a lot out of you. And a pro tip would be to wear shoes with good traction on them. I'm not sure if you can tell from the video, but every time I try to put pressure on this thing, I'm sliding on my shop floor, and that really made this a chore. Now, occasionally you'll see me hitting one end or the other with the spray bottle there. That's just water. And the idea is that I'm cooling down certain sections when I notice that those sections are twisting faster than others. I'm not really concerned about keeping a perfect uniform twist throughout the length of it. In fact, I kind of like that there's some random elements to it in that way. But if I can see that one section is just twisting and the other sections are just kind of, staying put, if I can cool off that section that's getting ahead of itself, and it'll allow the other parts to catch up. So that's what that's all about. This is a job, and you can see me struggle with it for a while here before I get up to where I want. I don't know exactly how many twists I put in it. I'm guessing about 15 to 20 complete rotations. That's really just kind of an artistic thing, and it's up to you. I've done twist patterns before with just 180 degrees. I think it looks nice. It puts like a wave in it. But this time I wanted to go a little bit more. As you can see, it's just kind of getting wormy on me here, so I decided to try to level it out a little bit with the hammer, and then we'll go back and twist it up some more. And once I'm satisfied with the twist that I've got in there, it's time to take it back over to the forge and start pressing it out again. And here's where I probably made my biggest mistake with this build. Really, after the twist, it would have been the best time to take it over the chop saw and cut it down into 2 pieces. But instead, I tried to work it out while it was all together here, and you'll see coming up here, it just gets too long and a little unwieldy, and it ends up kind of bending and takes that banana curve. And to add insult to injury, if you watch in this clip, you'll see that my hydraulic press foot pedal gets stuck a couple times, and it puts too much pressure at a couple intervals. Right there is one of them, and it happens again towards the top part of the billet. That's really frustrating. It didn't ruin anything, but it did make for a pretty ugly length of steel. And again, I should have just chopped it before I got to this point. It would have made it a lot easier to work with. When I do blade build videos with each of these individual billets, you'll see how I kind of work around that. But for now, I just thought I'd give a little explanation about what's happening. I do catch on here, and this is where I'll take it over the saw and break it down into 2 pieces, and things go a little bit better after that. And this is the side that I guess took the worst of the mishaps with the hydraulic press, and you can see this is the more mangled side. But there's still plenty of steel, and I kind of had an idea before I started this project that I wanted to make a long, slender dagger. And I think that will lend itself to it just fine. Not this one, but again, the previous piece there, you can see where the end kind of curls up. I think I can easily draw that out into a tang because I want that dagger to have a through tang, and ultimately it should work out pretty well for that. And then with this piece here, you can see I've got more than enough to do a knife with scales. I'm not really sure yet, maybe something, maybe like a camp knife or a fighter. I really don't know what I'm going to do with that one yet, but one of these is hopefully going to turn out to be a little stiletto style dagger. This is probably a good opportunity for me to give a little disclaimer here. If you've watched some of my previous videos, you may notice that I don't spend a ton of time with the hammer and anvil, and there's a good reason for that. As much as I have tremendous respect for people who have mastered this, it's just amazing to watch that skill and that art form. But unfortunately, it's probably never going to be me. I'm missing a couple fingers on my right hand, and in that same incident, I was also badly injured on my left shoulder and upper arm. I have some steel hardware, I guess titanium hardware, in my humerus and around my shoulder, and I'm missing about half of my deltoid. Ultimately, that leaves me in a position where it's just very difficult for me to swing a 2 or 3 pound hammer on an anvil with any real efficiency. I can do it, and I like to feel that connection to the steel. So whenever I get the opportunity to do a little bit here and there, I do get over there and I use those tools. But just to be frank, without the advent of this technology, without the hydraulic press or the power hammer, I probably wouldn't be making knives at all. I just wouldn't have the ability to do that. So I'm thankful for that technology, and I just thought I'd explain a little bit. There are certain things that you can't do without the hammer and the anvil. So I do get over there. For example, in the next knife build, you'll probably see me try to stretch out some of the steel around the ricasso if I do make that dagger that I was just talking about. And that's something that I'm going to want to do with a round-off hammer and anvil, and there's really no better way to go about it, even in my limited capacity. But yeah, I'm never going to be that guy, and that's just me. So yeah, I just thought I'd take a moment to explain that, in case any of you were wondering. So anyway, now that I've got it relatively flat, I'm just going to take it over the surface grinder here, and I think from here on out I'm just working with this piece, because the other piece, again, I am going to be doing a little bit of work on the anvil, but this piece is probably going to be more likened to a stock removal project. So I just want to clean the scale off of both sides just to get a look at this pattern. I'm not going for a finished surface by any stretch. Now you'll see here, and it becomes more apparent once we get it into the etch, there's some lines that diagonally cross along the length of the steel. They look like cracks, but they're not. What that is basically where the wrinkle of the twist just kind of pulled and stretched the steel, and basically those ran up and down the entire length on both sides. And that's just a natural phenomenon that happens when you twist metal. If I had kept it on the surface grinder for another 5 minutes, I would have ground through all of them and you wouldn't see them at all. And as you can see at the end piece there, that's a good solid chunk of steel, and there doesn't seem to be any inconsistencies, and hopefully that's the case throughout. But yeah, in case you're wondering about those diagonal crossing lines, that's nothing to worry about. Whether or not there are any voids or inconsistencies as a result of an improper forge weld or anything like that is yet to be seen. But those specific lines, those are accounted for. I know exactly what those are, and they do grind out. You can see I'm just kind of showing you what I'm going to work with. Hopefully work with. That one looks a little more rough, but again, it really is a solid piece of steel on the inside, I think. We're just seeing a lot of mess along the outer edges and on the close to the surface on either side. Hopefully that's going to be my dagger. But let's get back to this one right here. I'm going to drop it into the ferric chloride, and we'll take a look and see how this pattern came out. Now, normally if I'm working with a finished blade, then I will leave it in the ferric chloride for about 7 to 10 minutes to pull the pattern up to the surface. But in this case, I only put it in there for about 3 minutes. I just wanted to see the direction that the lines were running, the spacing, and all of that. As you can see, I'm just rubbing baking soda all over it, and that neutralizes the acid, and that'll keep it from continuing to etch or oxidize your steel. I think this looks really great. I love the waviness of it. I love how it changes directions and thicknesses along the length. I think that especially once you start adding your bevels and you go deeper into those layers, and it changes with the profile and with the thickness of the blade as it goes towards the edge from the spine, I think that's really going to look nice, and I'm very happy with this result. Well, I guess that about wraps it up for this video, and I hope that you'll watch as I turn one or both of these billets into a blade in my next videos. Of course, if you have any questions or comments, as always, just leave them down in the comments section. I'll definitely get back to you. Thank you so much for watching, and if you haven't already, please like this video and subscribe to the channel if you want to see more coming up. Alright, I'll see you on the next one.